Hey there, wanted to let you know this is an audio only podcast, and if you get your podcast on Spotify, you can go follow me there. All right, cheers. Hello there, ladies and gentlemen. Welcome back to the Ephemeris podcast. I'm your host, Aphelion. Thank you for joining me here after what has been, I feel like, a long 2 weeks since I recorded an episode. The episode that was meant to come out earlier was postponed just because. Very stressful year, honestly. I did need to take a break, and I was kind of running out of motivation a little bit, but we are back. And to celebrate the fact that we are back, we're gonna look into some stories today that'll bring something a little bit fresh to the episode. So, it's gonna be two stories today, really quickly, and the first one's gonna be about a day in the life of an astrophysicist, and then we're going to look at 10 best places to go stargazing around the world. I might make this like a little bit of a bonus episode, just because it's not what we usually cover, but without a further ado, nonetheless, let's get into the first story. So, a day in the life of an astrophysicist. What is the career of an astrophysicist like? We hear a lot about the studies they do on this podcast, but not everybody understands what it means to live like an astrophysicist on a day-to-day basis. So, yeah, I think this is a really interesting question that we can uncover here. My preconceptions going into this story is that quite a few, or a majority, of astrophysics careers involve pursuing academia or research at some institution, but I might get proven wrong here, because we might either see a reflection of that or a direct contrast. So we're going to look at two different people who have been a part of some articles written about this specific issue. So the first person we're looking at is Amber Straughn, who is an astrophysicist on the JWST science team at NASA's Goddard Space Flight Center in Maryland. The article begins with an explanation of Straughn's motivation to get into the field and her early academic struggles, but she would ultimately land herself a master's and doctorate degree at ASU, or Arizona State University, after graduating from the University of Arkansas in Fayetteville. Hopefully I'm saying that correctly. I like to hear about these kind of stories sometimes because it's a kind of a friendly reminder of this idea that, or it might be more of an opinion that I have, that the level of opportunity you get to contribute to astrophysics is not extremely different based on where you go to college, unless you're trying to win like a Nobel Prize in physics. I know that might ruffle some feathers because, people really love their prestigious colleges these days, but to me that's a bit of a hot take that I have. And doing research at like University of Arizona or Penn State or any such colleges gets you decent reputation, at least in terms of writing papers, despite having significantly less competitive admissions than, say, Stanford or Caltech. And the difference between going to a prestigious and non-prestigious college is just the universal prizes you get, because a lot of the universal prizes that people get for their work typically go to faculty at prestigious universities. But other than that, a noticeable difference can't be seen in who's doing the important research in the field of astrophysics. So yeah, bit strange coming from me, obviously, because I don't have any experience in the field, but I do have a lot of experience reading articles about work that's done by university students across the world, I guess. And oftentimes it's like you do hear from university research at Penn State or University of Arizona instead of like Kavli and JPL, stuff like that. No hate to any of the colleges I mentioned, obviously. Just a couple of examples, and there are also countless examples of very famous astrophysicists who don't come from the most prestigious colleges in the country. So, yeah, sorry about that digression. I know that's not a part of the article we're talking about, but just wanted to explain that fully. So, what we know about Amber Straughn, right? That's where we were at before we got into this whole hot take thing. She had an amazing success story. She went from failing her physics GRE exam twice to landing a job at NASA, and that brings us to our initial question, since we've already covered the context here. What is it like being in such a position on a day-to-day basis, right? Working on JWST and, working at a NASA facility. So her daily routine starts in the early morning. She has peaceful time before yoga and extensive science article reading, which makes up a bulk of the morning routine there. And when it comes to her actual job, she spearheads the preparation and team meetings for upcoming events, because, believe it or not, JWST has a lot of stuff happening behind the scenes, and there are a lot of events for such an amazing space telescope. A quote from the article states, "She is the scientific liaison for the JWST science team to NASA's communications and outreach teams, so it is her job to ensure the organization's public-facing content is scientifically accurate." As Associate Director of the Astrophysics Science Division at NASA Goddard, she shepherds the Astrophysics communication team of science writers, social media staff, and multimedia producers who share NASA's astrophysics stories with the world. So, yeah, you could describe her job as being a science communicator on behalf of NASA Goddard, because of all of these specific traits of her job and her position at NASA Goddard. So, I mean, this isn't an unfamiliar job for astrophysicists. I know I described a slightly different sort of career in my preconceptions, but because it's a NASA facility and, you have to have astrophysics people work at NASA facilities, this can be one pathway that you take as a career in astrophysics. And yeah, so other things that she does, she appears a lot on social media to produce space-related content. So yeah, that's one example of a career in astrophysics. Now, the next one, which is a lot more like what I imagined, is the career of Dr. Natalie Hinkel, who is a planetary astrophysicist at ASU. And it's kind of funny that we got another ASU graduate. I promise that's not on purpose. Hinkel does what is known as postdoctoral research, and this involves short-term positions that are like a couple of years long, where researchers are employed to study a certain subject or area within astrophysics. And these positions don't necessarily have to be at the same college. Some of these people do end up jumping around between universities. So Hinkel describes her area of research as pertaining to spectroscopy and spectroscopic analysis of exoplanets as host stars to understand the evolution of the exoplanet and its star, which is something we're not unfamiliar with. Not a very foreign concept. We have talked about spectroscopy before, and we've talked about exoplanets. But that does not necessarily mean that it is an easy job, because it requires cataloging element abundances in a star using absorption and emission spectra, and you have to be familiar with things like physical chemistry and inorganic chemistry, all of that good stuff to sort of link element abundances using spectroscopy. So, yeah, not an easy job. To get a job like this, Hinkel received a Bachelor of Science in Physics with a minor in Math from Oberlin College, and then she went to 6 years of grad school to receive a PhD when she was also doing research. So the research before the PhD is, research for a PhD, and after that it becomes postdoctoral research. In the future, Hinkel is looking to receive a full-time and more permanent position as a professor or researcher at an observatory, which oftentimes tends to be the sort of end goal of anybody pursuing academia in astrophysics. And in terms of what Hinkel does on a daily, she says it's usually programming, which most people may not know, but astronomy involves a significant amount of programming, no matter how ancient it is, especially when it comes to operating telescopes for observations and all that good stuff. Definitely some other important ways in which you need to use coding that I'm missing out on, but that's the one thing that pops up into my head. So yeah, coding and programming is an essential task for astronomers to be able to do. And for anyone wondering what the work hours for a postdoc is like, it's actually quite flexible. It's more autonomous than being in, a 9-to-5 office job where you have to work certain hours. But there's still deadlines and necessary workloads that you have to, undertake. And the pay is all right, typically $50K a year. I don't think academia is notorious for its amazing pay, so that is to be expected. But the best part of this article is the answer Hinkel gave when asked what her favorite part of the job was. And she says, quote, "I get to do what I love, no doubt about it. I get to do the research that is interesting to me with people that I enjoy on my own time. It gives you a real sense of drive, one that I appreciate very much." And that answer is very relatable. Not that I'm in this position myself, but I do like where Hinkel is coming from in terms of her purpose. And I'm not going to say much more than that because we're going to go on another tangent if I do. So, a similar example to Hinkel's career would be that of Dr. Chanda Prescod-Weinstein. Hopefully I'm saying that correctly. I apologize if I am not. What's unique about Dr. Prescod-Weinstein's career is the fact that she's the 63rd African-American woman with a doctorate in physics. And I might not get around to talking about this issue, but there is a serious lack of diversity in astronomy and astrophysics. And, that is highlighted by the fact that we can actually number the amount of African-American women who have received a doctorate in physics. But anyways, her research is into axions, which we've talked about that before, so not an unfamiliar subject once again. But she also does do work in the community to promote science in minority communities. And she describes it sometimes as saving marginalized minority physicists from bad scientific community traditions. Dr. Prescod-Weinstein's daily routine begins with waking up at 6 a.m. and starting her morning by listening to a Jewish prayer service and career radio station while drinking golden Yunnan tea, which is definitely not something I've heard of. Very unique, and you don't hear about people doing that very often. I'm pretty sure most people's daily routine just involves waking up and staring at a phone for 30 minutes these days. So, anyways, I digress once again. She starts her work at 7 a.m. reading articles about axions and continues her work into the day by traveling to her office, which happens to be the Physics Astronomy building. And she travels by bus. Now, her favorite part of the job is slightly different, but still speaks to the idea of being passionate about what she does. Quote, what I love most about my work, is the idea that there is an intimate connection between how the universe works and mathematics is still fascinating to me 24 years after I had first learned about what theoretical cosmologists do. So yeah, those are examples of some careers of astrophysicists and what their daily routines look like. Maybe very different from what you might imagine, but maybe sometimes similar. So that is our first story, and our second story, once again, is about the best places to go stargazing around the world. The article is pretty straightforward, but because I don't like the idea of just reading off of it, I'll try to make things as interesting as possible and analyze some of these choices. So the list here of best places to go stargazing around the world is curated by Travel and Leisure Asia. And in first, we have the Atacama Desert in Chile. Hopefully I'm saying that correctly. The major perks of stargazing here, from what I can see, are the altitude and the lack of light pollution. But it's also a dry climate, so overcast is quite unlikely. And a unique part about going to Chile to stargaze is the visibility of different constellations because it is in the southern hemisphere, and you get a different collection of constellations from there. There are possible cons to going all the way to the Atacama Desert. It's very remote. You have to get quite far from Santiago, Chile. The light pollution is not too bad in the towns around Santiago, but you do still have to travel very far for those. And yeah, if you want to get like absolutely no light pollution, you'll have to travel even further, as I said. So definitely a good place. Not a lot of cons, so it does make sense that this was put in first place. The next best place to stargaze is Natural Bridges National Monument in the Utah of the United States. It is 350 miles from Salt Lake City, and this area is indeed secluded from the light pollution of metropolitan areas and has some great attractions for that reason. It was actually identified or first certified as the International Dark Sky Park. It was the first one. And another way you can know for certain that this place is a great stargazing spot is by the photos of the Milky Way that are taken from here, which you may have seen before. These photos are known as the River of Light phenomenon, and it rises over the Ochomo Bridge. So, yeah, you may have seen that before, and if you have, then you'll know that this place is a great place for stargazing. Now, there aren't a whole lot of cons. It is a national park. Perhaps, I don't think the park gets too crowded. It is possible, to be fair, but for the most part, it is pros because of how far away it is from light pollution. That's probably going to be my main metric here of evaluating some of these spots. Now, in third place, we have Iramote Ishigaki National Park in Japan. And you wouldn't be wrong to assume that Japan isn't a great place for stargazing in general because of its high levels of modernization and urbanization. You might imagine that it's difficult to find places where the Bortle scale, which is a 1 through 9 scale used for measuring light pollution, you wouldn't be wrong in assuming that the Bortle scale in most of Japan doesn't go below 4. And all of that is true, but there's one exception to stargazing in Japan, and that is because far down south in the Yaeyama Islands, there is the Iramote Ishigaki National Park, and it has amazingly clear water for snorkeling, kayaking, and canoeing, but it also has clear skies for stargazing. The only difficulty is getting to the island, which can't be reached by airplane, and, the weather conditions can be variable because ultimately it is an island. But other than that, this island is all nature, and there's really nothing to criticize. Apparently, you can see 84 of the 88 constellations recognized by the International Astronomical Union from this spot. So, yeah, definitely a great place. Big con is the remoteness because, to not get light pollution in Japan, you got to travel pretty far. So that's third place. In fourth place, we have Kruger National Park in South Africa. And the park is huge and magnificent on its own. It's 7,500 square miles in size, and it's the largest game reserve in South Africa. But to add a cherry on top of that, It's got some nice night sky views with all that barren and unpolluted land, in terms of light. What makes this park even better is that the forestation, or the lack of forestation, leaves a lot of empty flat land, which makes it easier to observe the night sky. The only thing I would have to say about Kruger is that it's not completely in the wilderness. It just about steers away from the light pollution of Johannesburg. If you wanted to be in the wilderness, you'd have to go slightly west of the park to more of the northern Cape of South Africa. But I mean, if you want to get wildlife and stargazing in the same place, there's no better place than Kruger. So once again, good choice, justifiably in fourth. No complaints. The last place, or the last stargazing spot that I will cover is Mauna Kea in Hawaii. And I think we've talked about Mauna Kea. Forgive me if I'm wrong, but it is an amazing location, and you can kind of tell off of its notoriety. But let's be specific here about what's nice about Mauna Kea in Hawaii. So it's got an excellent elevation for stargazing, and it's got a 13,803 foot elevation at its peak. It's also one of the only places in the world where you can drive from sea level to nearly 14,000 feet in about 2 hours. So not a lot of worries about getting there, unless you lack the driving experience, or perhaps you get altitude sickness. Another important detail to note about Mauna Kea that comes from the article, quote, because Mauna Kea is so close to the equator, around 80% of southern hemisphere stars are visible from here too. In other words, roughly 85% of all the stars visible from Earth can be seen from Mauna Kea. So you're really getting the full picture there. And yeah, that's the fifth place, best place to stargaze in the world. I'm not going to go over all 10 of them because that would turn into quite a long episode, but I will mention the last 5 places that have been mentioned on this in this article. The 6th place is Pic du Midi. Hopefully I'm saying that correctly. It's in France. 7th is Kiruna in Sweden. 8th is New Mexico True Dark Skies Trail in the United States. That's actually a really good one. I've heard of that before, so no doubt that would belong on this list. 9th is La Fortuna in Costa Rica, and 10th is Los Angeles, California, United States, which I definitely don't agree with, because let's be honest, it's LA. Like, if you wanted to get away from light pollution, the last place you'd want to go is LA. I know they have the amazing observatories up there, which are at higher elevation, but most of LA is just not suitable for that kind of stuff. So yeah, again, because of how lengthy everything else has been, I can't fully cover all of the places here. I will try to leave the articles in the description for further reading, but yeah, that is the second and last article of this episode, and that concludes our episode here. Thank you very much for making it to the end of this episode. I appreciate your support for the podcast, and if you enjoyed listening and you're new around here, I would really appreciate a subscribe on YouTube if you are listening there, and a follow on Spotify if that is where you get your audio podcast. So apologies for the long break. I will mention that as we come to a close to the month of July, I'm probably going to take an even longer break, just because I'm currently in the transition process and I'm going to be off to college, and I don't know what my life will look like until the end of August. So I do want to, take a break from the podcasting stuff to figure all of that stuff out before I come back, hopefully in September, to start doing start making more content and possibly get some other people involved. Actually, that's gonna be my primary goal once I make it to college. But Yeah, I will try to produce one or two more episodes now that I'm back into the groove of things and not leave you um, waiting for content. And yeah, until I see y'all later next week, it is goodbye for me. Peace.